Good afternoon. This is Miss Xiao here, and today I will be sharing a little about factorization by algebraic identities. This is taken from Secondary 2, G2, and Secondary 2, Secondary 2, G3, and in the G1 class, it's tackled in Secondary 3. Okay. So all questions here are taken from Maths Tutor 2A by Casco Publications, and it's written by Lee and Go. All right, so let's dive into the lesson. Factorization by algebraic identities. Now, there are three main algebraic identities that we'll be looking at. And the first is the square of the sum of two numbers. Okay, we have a plus b square equals to a square plus 2ab plus b square. Okay, just take note that there are three terms for this algebraic identity. Other than that, the first term is an a square, the last term is a b square. Middle term, 2ab, has a sign plus or positive 2ab that follows the sign here within the factorized form, which is also a plus, an addition. Now, the second algebraic identity is the square of the difference between two numbers. So we have a take away b square. We have a square minus 2ab plus b square. Now, take note again that the first and the third term is a square and b square. So can you see the similarities? So what I'm going to do is I'm going to highlight the first and the third term of the first and the second identities are the same. You may also notice that the middle term is 2ab. But what happens to the symbol next to it? Well, the symbol that goes with it is the negative sign, and this negative sign corresponds to the negative sign within the factorized form. Okay, so what I'm going to do is I'm going to draw an arrow between both negative sign, between both positive sign in the two identities so that you're better able to associate the factorized form and the expanded form. Okay, now, if you're having a bit of trouble, let me just also clarify. On the left-hand side, where the brackets are, this is what you call the factorized form. And on the left-hand side, where you see no brackets, this is what you call the expanded form. Okay, now let's take a look at the third identity. The third identity deals with the difference between the square of two numbers. And that would be a square take away b square. A square take away b square can be factorized into a plus b times a minus b. Okay, now, so this third identity has got only two terms. We need to commit these three identities to memory. Memorize it from the left to the right. That means if I were to say, hey, can you tell me what is a minus b whole thing square? You have to tell me it's a square minus 2ab plus b square. And you also need to learn to memorize it from right to left. So if I were to tell you, if I were to ask you, what's the factorized form of a square minus b square, you need to tell me it is a plus b multiplied by a minus b. So both ways, you need to be very flexible in terms of telling what it leads to, the factorized form to the expanded form and expanded form back to factorized form. Okay, we move on. Now, how do we factorize something like that? Okay, so before we even jump into any form of factorization, we have to ask ourselves, is it the first, the second, or the third identity? So let's see. we count the number of terms. So how many terms are there here? We have 3 terms. X squared, first term, 2x, second term, 1, third term. Okay, now, so if there are 3 terms, that means it's either the first identity or the second identity, isn't it? We will have eliminated the possibility of it being from the third identity. Now, the next thing to observe would be the middle term plus 2x. The sign that goes with it, addition. So it's a positive x coefficient. Now, if it's a positive x coefficient, come back to the previous slide, you notice that it applies to the first identity only. So we would have narrowed this down to it being the first identity. Okay, so if it's first identity, let's recall how it looks like. It would be a plus b squared equals to a squared plus 2ab plus b squared. Okay, now, so this a squared plus 2ab plus b squared is this form where the question is being written out as. I'm going to copy the question and write it right below what we have over here. So what can we tell? We can tell that x squared is a squared. So from here, we could say that actually a is equals to x, isn't it? Since both have powers being squared, that means a must be x. Now let's take a look at the third term. We will see from here that b squared is equals to 1. If b squared is equals to 1, b would be the square root of 1, and that would make 1. Okay, since we could always say that actually 1 refers to 1 square, because 1 square is 1. So from here, we know the value of what a is, we know the value of what b is. So therefore, we could say that x squared plus 2x plus 1 is equals to, instead of a plus b squared, I'm going to replace a with x. Okay, then the next one would be a plus, and I'm going to replace now b with 1. So x plus 1 whole thing square. Next question. Factorize x squared plus 10x plus 25. Okay, let's come back to our observation. How many terms do we have? Well, we have 3 terms here. So 3 terms meaning that we are looking at either the first identity or the second identity. Next step, let's look at the middle term and we identify whether it's a positive middle term or negative middle term. Middle term means, by mentioning middle term here, I'm talking about the x term, okay? Because sometimes the questions may just rearrange the terms such that the middle term may not be an x term. So in this case, x coefficient is positive 10. So this would make a positive x coefficient. And with this, we could narrow down our choice to it being from the first identity. So again, back to the first identity, let's quote from memory, a plus b squared equals to a squared plus 2ab plus b squared. Okay, now again, what I'm going to do is I'm going to copy down question, it being x squared plus 10, pardon me, x plus 25. Okay, now let's do a one-to-one comparison of the terms. So if x squared is a square, we can say that a is x, right? And the last term, we have b squared equals to 25. So if b squared is 25, we could rewrite 25 as 5 squared. So therefore, b is equals to 5. Okay, now we have the values of a and b. So we can factorize x squared plus 10x plus 25 equals to a plus b squared. Now a is x, b is 5. So x plus 5 whole thing square. That's how we factorize the second question. Third one. Oh, okay. How many terms now? So you would have noticed that this has again 3 terms, which leaves us to either the first or the second identity. Look at the middle term, identify the sign. So the y coefficient is -6, which means that it's a negative coefficient. This would mean that we are looking at the second identity. Let's write out the second identity from memory. A minus b squared equals to a squared minus 2ab plus b squared. Okay. And I am going to write down the question given y squared minus 6y plus 9. Next, we do a one-on-one term comparison from the first and the third term. Okay, we can see from here, a squared is y squared, and therefore a must be y. From the third term, we can do a comparison, and we see here that b squared is 9, and 9 can also be written in the form of 3 squared. So we could safely say that b is equals to 3. Given the values of a and b, we can now factorize our answer. Y squared minus 6y plus 9 must be a minus b squared. A is y and b is 3. That's it. Fourth question. 3 terms we have, yes. And so that brings us to either the first or the second identity. Moving on, we will also see that the middle term is, or rather the x coefficient is negative. Negative coefficient of x. Ready to factorize? Well, if I may also add on one more observation, is to take a look at all the coefficients in this question. They are actually factors of, or rather they all can be divided by 4. Yeah. Okay, so what I'm going to do first is I am going to factorize this question by common factor. So we have 4x squared minus 8x plus 4. If I factorize by common factor, my common factor is 4 because all terms can be divided by 4. So when I bring out 4, I'm left with x squared minus 2x plus 1. Okay, now within the bracket, how can I further factorize this? This looks like an a squared minus 2ab plus b squared, isn't it? Okay, so if I were to do a comparison, okay, let's see, between x squared and a squared, we can tell here that x is equals to a, or rather a is equals to x. Let me write it the other way around. And for the second portion, we have 1 equals to b squared. So we could say that b squared is equals to 1. And 1 can be also written as 1 squared. So therefore, b is equals to 1. And if we were to do a further factorization, we'll leave the 4 outside. So from here, we can tell that while a is equals to x, b is equals to 1, it would be factorized to give us x minus 1 whole thing squared. So we can see 2 rounds of factorization from this question. Moving on, we have factorization of 4x squared plus 20x plus 25. 3 terms. So we can see that this is taken from the first or the second identity. The x coefficient is positive. Which leads us to a plus b square, which is a square plus 2ab plus b square. Let me write down the question below, and it says 4x squared plus 20x plus 25. And let's do a one-on-one comparison. Now, a squared is 4x squared. We have to think about how we want to manipulate our 4x squared such that it can be an entire number with a square outside. And that entire number here would be a. So we look at the coefficient, which is 4. We square root it. So when we square root 4, we get 2. After that, let's look at the x squared. And we are also going to square root it as well. So when we square root x squared, we will end up with x. So within the square number is 2x. Let's verify this on the side. So if we want to consider 2x whole thing square, you know that when we square any number, it's that number multiplied by itself 2 times over. And this gives us coefficient 2 times 2, 4, x times x, x squared. Okay, so 4x squared is indeed bracket 2x, close bracket, square. Here, we can see that a is equals to 2x. Now within b, b squared is equals to 25. And we also know that 25 can be rewritten as 5 squared. So therefore, b is equals to 5. Knowing the values of a and b, we should be able to factorize it now. And so for x squared plus 20x plus 25 can be rewritten as 2x, this is a, plus 5, which is b, and whole thing square. Next question, how many terms? 3 terms. Okay, so an observation, 3 terms. So we are looking at the first or the second identity. And the middle term in this case is actually an xy term. Xy term is negative. So we narrow down our search to the second identity. Now, second identity is written as a minus b squared, which gives us a squared minus 2ab plus b squared. And in our question, if I were to write it down, it would be 9x squared minus 12xy plus 4y squared. Let's do a comparison now. So with a squared being 9x squared, if I were to rewrite 9x squared into something square, I need to look at the coefficient of x squared and square root it. So we square root 9, it gives us 3. We look at the term, which is the x squared term. We square root it, we get x. So it's bracket 3x squared. Now let's look at the, So from here, we can actually tell that a is equals to 3x. Now, following that, we have b squared being 4y squared. And again, how do we put it as the square of a certain number? Let's square root the coefficient as well as the term. So coefficient is 4. We square root 4, we get 2. The term is a y squared term. We square root y squared, we end up with y. So therefore, from here, we will be able to see that b is equals to 2y. So 9x squared minus 12xy plus 4y squared is a minus b squared. A is 3x minus b is 2y and whole thing squared. Next, we move on to the question that has now 2 terms. Wow. So if there are 2 terms, let's go back to the previous. Okay, so this is the third identity, and we're looking at the difference between the square of 2 numbers, a squared minus b squared. So we're looking at third identity, okay, which gives us a squared minus b squared. So let us form x squared minus 36 into something square minus something square. You can tell here, from here, that a squared is x squared, and therefore a is equals to x, right? Now, let's do another comparison. We have b squared being 36. So if b squared is 36, we can also change 36 into 6 squared, and therefore b is equals to 6. So in factorization, it will be a plus b. Perhaps let me write it down. We know that a is x, b is 6. So when we factorize, we have a plus b, which gives us an x plus 6 multiplied by x, a minus b, which is x minus 6. So this is its factorized form. Next one. Okay, here we have, again, 2x squared minus 50, 2 terms. And apart from that, well, with 2 terms, it would be definitely the third identity we're looking at, right? Okay. If you want to look at it being the third identity, we have an a squared minus b squared, which is a plus b, a minus b. Now, it's a bit odd here because x squared, the coefficient is 2, and how are we going to factorize it? If you factorize 2, it will end up with a square root of 2, which will not be a nice number, right? It won't be a whole number. And if we look at 50, right? If we were to square root 50, we'll get root 50. And that will not give us a nice number either. So before moving forward to start to factorize by identities, is there another way that we can simplify this whole thing? So if we look at 2 and 50, don't you think that we could actually factorize by common factors first? So let's divide 2 from each of the terms. And there we go. Within the bracket, what I can see from here is an x squared and 25. Just nice, both are square numbers. Yeah. So we can see from here, in comparison, if a squared is equals to x squared, so therefore a is x. If b squared is equals to 25, 25 can be rewritten as 5 squared, therefore b is equals to 5. Now that we have the values of a and b, well, we could write them down already in the factorized form. Within the first bracket, a plus b, I'll write it as x plus 5. And the second bracket, a minus b, it will be x minus 5. So this is the factorized form. And lastly, let's take a look at this question. It looks quite challenging. Regardless of how challenging it is, please take note that it will always fall back to the 3 identities. And we observe, now we have 2 terms. With 2 terms, it will definitely be the third identity. Straight in here. All right, so let's see, we have a squared, take away b squared, and that would be an a plus b multiplied by a minus b. We have a 16x squared, y squared. Oh, okay, this one looks tough. Minus 49y squared. Now let's do a one-on-one comparison. If a squared is 16x squared, y squared, that means a would mean that we have to square root every single term in here. So let's start from the coefficient. If we square root 16, we end up with 4, right? If we square root and okay, maybe let me put it in another way. We'll change it to something square. Let me make the teaching a bit more uniform. So we square root 16, we get 4. Let's square root x squared now, and we end up with x. Okay. And lastly, we square root y squared, we end up with y. So 4xy bracket square is actually 16x squared y squared. We'll do the same now for the next term, where we have b squared being 49y squared. So b squared equals to 49y squared. How can we write it as something squared? So let's go about square rooting the coefficient in each of the term. So 49 being coefficient, we square root, we get 7. Y squared, we square root it, we end up with y. So now we have a being 4xy and b being 7y. Okay. So let's factorize it. So we have 4xy plus 7y, 4xy minus 7y. Are we done? Not quite. Now, do you notice that within each of the brackets, we can factorize y out as a factor. So when we factorize y out of the first bracket, we will end up with y on the outside, 4x plus 7 on the inside. And the second bracket, we can also factorize y out, and we end up with a 4x minus 7. Last step, what do we need to do? There's so many letters everywhere. Well, we could combine this, the two y's, to put them together. So we know that y multiplied by y will give you y squared. So this would give us y squared multiplied by 4x plus 7 multiplied by 4x minus 7. And this would be our finished solution. So I hope that this short sharing would actually help you to be a bit more confident in factorization using algebraic identities. It's not easy, because it's something very new, but with practice, it always gets easier than the last time you tried. So don't give up, keep trying, and all the best. I'll see you in the next recording. Bye.